Welcome back. So in today's video we'll see how to use BigM method for solving a linear programming problem. Okay, so in the previous lecture we had seen how to use a simplex method, and in a simplex method we always have a less than or equal to constraints. Okay, so when we have a less than or equal to constraint, we can simply use or we can add a slack variable, and these slack variables, since we are adding them, that coefficient will be 1 and they will go to the basic variable, or they can be considered as a basic variable. But here if you see, we have the constraints as greater than or equal to. Okay, so in such cases we have to subtract a variable, then only we can make that into a equality. Okay, so for example, when I am writing the canonical form, I can make this equation as 2x1 plus x2. This if I subtract something, okay, minus s1, then it becomes equal to 10. Okay, but the problem now is that we do not have a basic variable in this equation, because as per definition the coefficient of basic variable should be 1 in one of the equations and 0 in others. But here we have s1, the coefficient is minus 1 and not 1. Okay, so in order to avoid that issue, what we do is we add a another variable, artificial variable. Okay, and we denote that by r1. Okay, in this case now we have a coefficient variable with coefficient equal to 1, and we can have the coefficient 0 in the other constraints. Okay, so similarly for the second equation, it becomes x1 plus x2, then we need to subtract another variable minus s2, and we have to add a artificial variable. Okay, so here it won't be r1, instead it will be r2, so that becomes equal to 6. And for the third one, it's already less than or equal to. Okay, so here I can just write minus 3x1 plus 2x2. Now I can just simply add a slack variable plus s3. Okay, and that can be equated to 6. So in this case I have a coefficient with I have a variable with coefficient 1, and I do not have s3 in the other two, so the coefficients in the equation 1 and equation 2 are 0. So that means s3 can be the basic variable from this particular equation. Okay, so we get the three basic variables r1, r2 and s3. Okay, so you have to keep that in mind. If you have a mixed inequalities, like some equations are greater than or some equations are less than, in such cases you can always go for BigM method, and you always have to add that artificial variable for all the greater than or equal to constraints. Okay, suppose one of the constraint was equal to like suppose this was x1 plus x2 equal to 6. Okay, in that case also we simply add this artificial variable, but we do not include a s2. Okay, so keep that also in mind. And now let's so we have the constraints for the in the canonical form, and similarly the objective function also changes. So z becomes 4x1 plus 3x2, and all the s variables will be having coefficient 0. So 0 s1, 0 s2, 0 s3. But we have two artificial variables also, and for the artificial variables we introduce a coefficient m, where m is a large number. Okay, any large number. So we have m r1 plus m r2. Okay, so this will be our new objective function, and these are the constraint equations in the canonical form. Okay, so now let's write the initial simplex table. So all that remains the same as in the simplex method only. We have the basic variables as r1, r2 and s3. Okay, and then we write the all the variables here. So x1, x2, then we have s1, s2, s3, and r1, r2. Okay, so we have all these variables now, and we need to write the corresponding coefficients. Okay, so from equation 1 we have the coefficient of x1 as 2, then x2 is 1, s1 is minus 1, s2 there's no s2, there's no s3, r1 is 1 and r2 is 1, and we also write the right hand side. Okay, so that is 10. And for the second equation we write 1, x2 again 1, s1 will be 0, s2 will be minus 1, s3 is 0, r1 equal to 0. For r2 the coefficient is 1. Okay, and the right hand side will be 6. And for the final one we have a negative 3 over here for x1, then 2, then 0 0. For s3 it will be 1, and again we have r1 and r2 0 0. Okay, and the right hand side is 6. And we need to also write the cj values, that's the coefficient from the objective function. So for x1 we have 4, x2 3, s1 0, s2 0, etc. Okay, so I'm just writing the values over here. So I have 4 3 0 0 0, and for r1 and r2 we have capital M as the coefficient. Okay, and then we also write the coefficient values here. So for corresponding to r1 we have M, and corresponding to r2 also M, and for s3 0. Okay, so these are the values which are coming directly from here, from the objective function coefficients. Okay, and now we have the initial simplex table, so we can just calculate zj. Okay, so I can calculate zj now. So zj will be calculated exact same manner as in the simplex one. So here what we do is m into 2 plus m into 1 plus 0 into minus 3. Okay, so that will be 2m plus m, 3m, and here it will be m into 1 plus m into 1 plus 0 into 2. Okay, so that's m plus m, 2m. Similarly here you have minus m, 0, m, and again m. Okay, and now we also write the cj minus zj value. So in this case this will be 4 minus 3m, this will be 3 minus 2m, this will be positive m, then we have zeros over here. Okay, and in simplex when we had a maximization problem, what we did was we chose the maximum positive value of cj minus zj, and for minimization problem, okay, so for minimization problem we take the least or the maximum negative value. Okay, so for minimization the optimality condition is cj minus zj all should be greater than or equal to 0. So unless we reach this condition we have to iterate. So here we select the maximum negative one, and since m is a large number, minus 3m will be a large negative number. Okay, so this will be our pivot column. So we divide, for getting the ratio we divide the solution values. So this is the solution value, so 10 6 and 6, we divide that by 2 1 and minus 3. Okay, so we get 10 by 2, so that's 5, 6 by 1 6, and 6 by minus 3, that will be minus 2. Okay, and yeah, so here we take the minimum ratio, but you have to keep in mind, I mentioned in the previous video also, if we have a negative value we just simply ignore that. Okay, we do not consider that at all. So here we just check only the 5 and 6, and the minimum will be 5. So that means our pivot row is the first one. So this was the pivot column, first is the pivot row, so this will be our pivot element. Okay, so that means x1 is going to enter and r1 is going to come out from the basic variable. Okay, so let's just write that. So now the instead of r1 we can write x1, R2 and S3 remains the same. Okay, and the coefficient of x1 is 4 from the objective function. For R2 it's m, and for S3 it's 0. Okay, and yeah, now we need to do, or we need to first convert the pivot element to 1. Okay, so for that I had to divide the first row. So this R1 denotes the row 1, okay, not our artificial variable. So the row 1 changes to half row 1. Okay, we are dividing by 2. So here the variables changes to 1, then we have 1 by 2 minus 1 by 2, so minus 1 divided by 2, then 0 0 1 by 2 0 and 10 by 2, that will be 5. Okay, so we have the first row, and then what we need to do is we have to make the this element, that's 1, from row number 2 to 0. Okay, so for that we have to do this operation. The row 2 should change as row 2 minus row 1. Okay, because we have a 1 here and the value here is also 1, so we just write 1 minus 1. So if I am performing that calculation for the entire row 2, what I get is I get 0, then half over here, again half here, minus 1, 0, minus half, 1 and 1. Okay, and for R3 we have a minus 3 here, and to get this 0, what we need to do is for R3 we can just add R3 with 3 times R1. Okay, so this is minus 3 over here, so if we just multiply this R1 with 3 and add it, you get a 0. Okay, so 0, then this becomes 7 by 2 minus 3 by 2, 0 1, 3 by 2, 0, and this becomes 21. Okay, so that will be our first iteration. We have it complete. Then we can calculate zj, and then first we calculate zj and then we calculate cj minus zj. Okay, so here zj, in this case this will be 4, here it will be 2 plus m by 2, and here it will be minus 2 plus m by 2, and this will be minus m, and it will be a 0 over here. Okay, 4 into 0, m into 0, 0 into 1. Okay, 0, and then here we have 2 minus m by 2 and m over here. Okay, and now when we are doing cj minus zj, what we get, I'm not doing the whole thing, we just have to see which will be the maximum negative. Okay, so here I had the value 3 and here it was 0, so this will be 3 minus 2 plus m by 2, and this will be 0 minus 2 plus m by 2. Okay, so that makes this should go to 0. This will be 1 minus 1 by 2 m, and this will be 2 minus 1 by 2 m. Okay, so minus m by 2 is a large number, and if you are subtracting that from a smaller number here, okay, 1, comparing 1 and 2, 1 is the smallest number. So if you are subtracting minus 1 by or m by 2 from 1, this will be the smallest of the two. Okay, so this will be the maximum negative number here, and so this will be the pivot column, and once we divide the solution we get 5 1 by 2, so that will become 10, then we get 2 over here, and for 21 by 7 by 2, that gives 6. Okay, so the minimum ratio here is 2, and then that gives us the pivot element as 1 by 2. Okay, so that means R2 is going to leave from the basic variable and x2 is going to enter. Okay, so we can just write those. Okay, so now x1 stays as it is, and R2 leaves and x2 enters, and s3 leaves as it is. Okay, so for x1 the coefficient was 4, x2 3, and s3 0, and we okay, and now we have to make this 1 by 2 as 1. So what we need to do is that we are treating row number 2. Okay, so row number 2 should change to 2 times row number 2. Okay, so that way we get a 1 over there. So yeah, let's calculate that. So we have a 0 here, and then 1 over here, and again 1 minus 2, 0 minus 1 and 2 and 2. Okay, so we have these values here, and yeah, for x1 we had half here, so in order to change that we need to do this operation, r1 changing to r1 minus half r2. Okay, so once we do that, we get the following values. So we have 1 0 minus 1 1 0 1 minus 1 and 4. Okay, and for s3 we had 7 by 2 over here, so in order to get a 0 over there, what we need to do is the row number 3, it changes as r3 minus 7 by 2 r2. Okay, so once we do that we get 0 over here, then this should be 0, and we get minus 5 over here, 7 1 5 minus 7 and 14. Okay, so this is what we get, hopefully, if I have not made any calculation mistakes. And now we have to calculate zj again. Okay, so in this case this will be 4, now this will be 3 over here, and then here we have minus 4 plus 3, so that will be minus 1, 4 minus 6, so that's minus 2, then 0 0 0, 4 minus 3, 1 plus 0. Okay, so we have 1 over here, and then 6 minus 4, that will be 2. Okay, so now again cj minus zj, this becomes 0, this becomes 0, so this cj, corresponding cj was 0 here, so this becomes 1, this 2, 0, this will be m minus 1, and this will be m minus 2. Okay, since we had this cj values over here, right? Okay, now if you see, all of these cj minus zj values are positive, right? So we have reached the condition where all cj minus zj is greater than or equal to 0, and that means we have reached the optimal solution. Okay, and so our solution will be this x1 should be 4 and x2 should be equal to 2. So the x1 value will be 4 and the x2 value will be 2. Okay, so that's our solution, x1 equal to 4 and x2 equal to 2. And if we substitute the values in the objective function, z was 4x1 plus 3x2. Okay, so 4x1, so that's 4 into 4 plus 3 into 2, so 16 plus 6 means 22. Okay, so that is the value for the objective function, and these are the solutions we obtain. Okay, so I hope BigM method is clear. The table calculation, everything is the same as a simplex, but what we just needed to do additionally was we had to introduce this artificial variables, so that we have some coefficient, or we have some variable with coefficient +1 in one of the equations and 0 in the others. Okay, so that's the difference. And simplex you can use only if there is a if there are only less than or equal to constraints, but if you have greater than or equal to or equal to, you need to go for BigM method and not simplex method. Okay, so I hope that's clear, and thank you for watching.